All right. So I'm going to start off by saying practical zero-knowledge proof is a misleading title because not everything is ZK here. So I'll kind of make the first question to Remi. In a couple sentences, tell me about what Inco Network is and what's behind powering it.
So hi everyone, I'm Remi. So I'm the founder of Inco Network. Inco Network is an EVM with on-chain confidentiality. And this is leveraging a new cryptography called fully homomorphic encryption.
I'll maybe, we'll come back to that in a second. Kautuk, for you, what is Stackr and how is it different from other ZK rollups?
Hey everyone, my name is Kautuk. I'm building Stackr. It's a micro rollup framework. And with micro rollups, we are taking an approach of going back to the roots and defining what rollups are and should be. And with that, it enables people building rollups in general purpose languages. And we are offloading the execution part from the verification part with that.
Amazing. I'm liking the concise short answers. We'll leaves up a lot more room to actually go dig in. And then finally, tell us about what you're working on.
So I'm currently working on Kakarot. Kakarot is basically it's an EVM written in Cairo. And because it's written in Cairo, Cairo is a provable language. Basically, whatever you execute in Cairo, you can generate a proof, which turns Kakarot into a ZK-EVM. The Kakarot team itself, we are not working in low cryptography aspects. So yeah, Kakarot is a layer 2. It's an EVM written in Cairo that will settle on Ethereum.
And maybe for the audience that doesn't know what Cairo is, can you also just give us that context on
Yeah,
why?
so Cairo is a language developed by the Starkware team, which basically it generates execution trace that can generate Stark proofs. So it's a domain-specific language that can generate Stark proofs.
Amazing. So you have the ZK-SNARKs, and then with Cairo, you get to do ZK-STARKs.
Yes.
Coming back to Remi, so what is FHE? And give us a slightly more better intuition around what does homomorphic encryption mean?
Yeah, so FHE is a different type of cryptography compared to ZK. FHE is lattice-based. The way to think about FHE, let me give you an example, which is imagine you have a picture. You encrypt that picture and send it to me. I have your encrypted picture, but I can still make modifications on your picture. So let's say I can add some values to the RGB values or subtract or multiply. I can essentially change the pixels on top of your encrypted data. And by the time I send it back to you and you decrypt, you have this automatic new filter applied to your original picture. So FHE essentially is a cryptography that allows you to encrypt data, but also do all sorts of operations, mathematical operations, transformations on top of encrypted data. So what we're doing here is we're adding FHE into an EVM. The idea is that today all the EVMs are completely transparent and public. And so for us, by enabling confidentiality on chain, it means that you can store things directly in an encrypted manner directly on chain. And so for example, if you to build a poker game, you can directly store encrypted hidden cards on chain. And if you were to, let's say, build any DeFi applications or any applications that require state transition on top of encrypted data, this is where we can leverage FHE to do state transformation. So what this essentially means that we can enable composability on top of encrypted data directly on chain. So imagine if everyone here submits the hidden price of Bitcoin, we can still compute the average price of Bitcoin in a hidden manner using FHE without having to decrypt during this entire process. And more broadly speaking, I think gaming would be also quite interesting because today when we build games on EVM chains, everything's public, all the game states, player stats. But for us, fundamentally, we can enable novel types of games that have to do with bluffing. You can sabotage, you can spy on people, you can consume resources. The idea is bringing this kind of more Web 2-like experience to Web 3. If you think about this today, when people come to Web 3, they will often realize that they can only build use cases that make sense on a transparent database. But this is not how Web 2 works. What if you want to build a poker game, right? What if you want to hide some information? So this is where I think for us, the idea is we want to bring novel experiences and allowing people to build applications that are a little bit more flexible in terms of what to hide and what to leave public. And this is fully cryptography based. So, there has been other type of solutions leveraging either secure enclaves or ZK based off-chain. for us, what differentiates us is that this is all happening fully on chain, which makes it very easy to build any applications that require any coordination. Yeah.
No, that's amazing. Maybe I'll just ask one more clarification there. Could you also give us an intuition around how does the doing operations on encrypted data differ in FHE versus something when we hear this is ZK based?
Yep.
Does that mean you have to decrypt it? Does that mean it's never public or it has to be publicized? What's a good way of thinking about that?
Yep, that's a really good question. So everything you do ZK typically happens off-chain. So from the data you're trying to hide to the prover to the circuits. ZK fundamentally is a proof of compute. So a lot of the state transformation has to happen off-chain over plaintext. What's different about FHE is this can happen directly on-chain on top of encrypted data. So this is where, if you're to do any coordination use case that require any composability with ZK, it will become a lot more complex because you need off-chain coordination, but also off-chain, basically computation over plaintext to generate a new ZK proof. FHE, on the other hand, anyone can just submit a hidden transaction directly on-chain. The shared private layer directly happens on-chain, so you don't need any off-chain, coordinator, and yeah, it's all cryptography based. Yeah.
Amazing. I also don't want this to be like a one-by-one thing. So obviously you are all in the same ecosystem. Feel free to add on or disagree or agree, whatever you want to do. My kind of next question is for you, Kautuk. What is a micro rollup here, and why a micro rollup instead of just going to some ZK rollup that already exists?
Right. So I think in the current space, we have like a particular mental model of what a rollup is and how apps are developed on top of a rollup. But at some point, we are forgetting that why do we need a rollup? Like the rollup is used to have an off-chain compute model which does some stuff and it's verifiable on-chain. We are building rollups which are like chains. We are deploying apps on those chains, and those are limited by the VM of the chain. So how we see rollups is that, okay, you build a state machine, and that's what Stackr allows you to do. You build your own state machine, and you build that state machine according to your logic and whatever your business logic is, whatever the computation that you want to do.
Could you give us a more specific example of what that would look like?
Okay, so right now, if you want to do a token transfer, right? So you write a smart contract, which is an ERC20 smart contract that runs on an EVM-based blockchain or something else. But how about you ingrain that token transfer logic within the state machine itself? So the state machine does nothing but token transfer and does it very efficiently. And you take that state machine and you make it provable, and that's how you achieve like extreme level of compression and also extreme level of cost effectiveness, and obviously like the throughput is also a byproduct of it.
So if I'm understanding this right, does that mean I don't need to necessarily write Solidity code?
Yes. So you can kind of build these rollups in any general purpose languages. You like Rust, you like JavaScript, you like Go, you can do whatever with it. You just define your state, you define how the state is modified, and the SDK takes care of it so that it rolls up into blocks. All the blocks goes to another layer. So we have a verification layer in between, which is kind of like a prover marketplace. So it runs for in between all the applications and L1 and proves the computation through different methods, and you can tell how you want to compute those proofs, and that goes on chain.
Amazing. And I'll say this in the nicest possible way. Why did you do it on Cairo? That's a lot of work to make EVM compatible DSL. Tell us about what the challenges were. I don't mean this in a negative way, but like that is very complicated. So why did you decide to spend the time to make a EVM compatible DSL?
Yeah, I think the first thing was that it started as an interesting challenge. It didn't start, let's build a company and like, no, it was like, this looks fun. We have a 1 week hacker house and hackathon. Why not try to do this, right? And ended up where we are. And as we went, what we realized is that the first is that Cairo is a hard language to start with, but once you get the grasp of it, there's not much you can do. It's like very limited, similar to how Solidity compares to JavaScript. Like once you get a grasp of it, you have the whole map. So it's hard to start, but once you start, you can get good really pretty fast. And the second thing is that if you want to build a ZK-EVM today, like ZK Sync, Scroll, Polygon ZK-EVM, all of these teams, they are building in circuits directly. That's much harder than writing in Cairo itself. So And there's a trade-off, right? Like Kakarot is almost like a VM on top of another VM. So it's an EVM on top of Cairo VM. So there is an overhead. And there might be some like inefficiencies compared to writing circuits directly. But there's a lot of also positive trade-offs, such as it's much easier to audit. The Kakarot ZK-EVM has a code base of 10,000 lines of code. You will find a lot more Cairo auditors than pure circuit auditors. And the second thing is that we can move faster. For example, when the push 0 opcode was released, and our code base was 5 lines of code. It's like writing on a lower level language instead of having to deal with polynomials and all the math stuff. And so we really believe that DSLs has a bright future, especially like with applications that can be provable in parallel, and you can fast iterate provable backends. And also there is one thing, like even this was from the Cairo team, is that they first started doing circuits for DEX, NFT marketplaces, but then they realized, oh, every time we do an application, we need to do all these circuits and we need to like do all these polynomials, and it's really hard. So that's the reason why they thought they developed Cairo. Is like, okay, we rather have more time and less efficiency than have to spend more time and be a little bit more efficient. And what they realized in the end is that even though they had this overhead, the Cairo version was more efficient than the pure circuit. And that's because when you have a more human readable language, you can design algorithms that are more efficient than when you're just doing circuits. So it's like, let's say you're writing a program in bits. Like you can be a lot more clever and efficient if you're writing in Python, for example, compared to writing in bits. So like there's some advantage of DSLs, and we believe that on the long run, because we can move fast and we can implement things and iterate things faster, that's where our advantage is.
Awesome. So I guess one follow-up that I have then is, if Cairo is already a abstraction on not writing a lot of the circuits and polynomial math, what was kind of the reason that you wanted EVM there? You want just people to just deploy same contracts there, or is there a different answer, or does it enable more things?
I guess is for us, having that choice is what allowed me to be here on the Ethereum ecosystem. So we truly believe in the power of SNARKs, but we also truly believe in the what is already being built in the Ethereum ecosystem, like all the technologies that are being developed. So we wanted to, we saw a market that wasn't explored and say why not, right? And yeah.
No, that's great. I was going to say, are there any limitations of ZK-EVM here on top of Cairo, or is it 100% compatible and we can do everything that I would be?
Right now we have all the opcodes, and we have 8 of the 9 precompiles. And we are just missing one, which is the EC pairing. It's a little bit harder because of the Cairo field, the size of the field of Cairo. But I think that's a matter of time. And I would say that the only pain point or the biggest challenge would be how to make it efficient. Not just 10, 20 TPS, but how can we get to hundreds and thousands of TPS, which is the goal of our rollup. So, but I think the Starkware team is doing a great work. There is every year there's a lot of development on the ZK space. So it's just a matter of time.
Amazing. Remi, you also chose to do EVM for your FHE. Tell us about why EVM is important in the context of encryption.
Yeah, so technically we could build this VM with different languages like Solana or even Move. EVM is to us by far the most adopted, Solidity is by far the most adopted smart contract language. And also by far, all the Ethereum tooling ecosystems like MetaMask, Hard Hat, Remix is also by far the most adopted tool sets. So for us, it was kind of a no-brainer to, just start with that. And the idea is also generally when people come to a new ecosystem, it's always quite a friction point to learn new tooling. Also getting new wallets and understanding, new debuggers and things like that. So, just being able to reuse existing tool sets that are pretty well adopted is, to us, is quite a practical way to approach this. Yeah.
Amazing. You interestingly chose to not necessarily have an opinion on EVM compatibility because you want to enable a lot more. So maybe my question is different, which is tell us about more real world use cases that you think will now be enabled if people don't have to worry about learning Solidity.
Yeah, of course. I think, I have opinions about ZK-EVMs, but so far...
Let's get into it. We got time.
All right. So what I feel is that what's our mission as a Web3 developer community? Is our mission to build the best tech possible, or is our mission to get Web3 the maximum adoption out there? So obviously nothing is right or wrong over here. We can definitely build the best tech out there. We can have amazing cryptography. We can have amazing systems which are really good and preserves privacy and solves almost all the problems with centralization. But at the same time, at what cost? Like if you're building systems like ZK-EVM or we have like the Solana system, which is very, very compute intensive and very difficult to manage, does that really reach out to masses? So that's where I kind of like differ in that. I mean, like obviously ZK-EVMs are a great solution, but again, it's like the adoption part which is the problem. So ZK-based systems are very expensive, and ultimately the cost is borne by the users. So is it really worth it? So that's my take on it.
No, that's still totally fair. So in this case, maybe show us like what a hypothetical use case would look like on Stackr, and who would be responsible for what in that example?
Right. Again, going a little bit deep into like the thought processes. So there is crypto, and then there's Web3, right? And most of them, most of the times, it's kind of an overlap. But crypto is more of a application-based thing, and Web3 is more of a thought process. That the process of decentralization, of unownership, of giving things in control, the data getting in control of people. So with Stackr, like that is the part where we're focused on, which is the Web3 part, on bringing existing applications which are centralized, have some limitations, and bringing them and opening up the data part of it or the execution part of it. So one example I keep going back on again and again is the ride-sharing app platform. So right now it's centralized. Everyone is on the mercy of the companies on finalizing the prices. The drivers are not getting paid well. The people are not finding drivers. So how about we decentralize that part of it, wherein the ride sharing part, or the place when you request a ride and the driver accepts it, make that a matching engine. That's something which can be put on chain. And I mean, like, obviously, we need to get there to make it more accessible to other people, but that's a very nice use case. So there are a lot of Web2-based applications which can be ported into the Web3 space. So another example could be like the ticketing tool. So for concerts and all, people just stay there in line and nobody knows about it and what's the process. And if there are even tickets available and nobody ends up getting tickets, and otherwise it's just on black market, just at bloated up prices. So everyone knows that. So that's a very good use case for like making things transparent and like making things more accessible. And also, if we think about social consensus around it, like we're in the community of fans who are very, very into that, and they're not in for the business or the money part of it, they can become the validators or verifiers of those systems. So ultimately, it's about like the sequencing part. All of those things can be handled by the community. The social consensus kicks in, and everyone just has an ownership of their ecosystem. So those are the kind of use cases which I feel we should think more of, and we should think building more of. Yeah.
No, that's amazing. Like. Nobody disagrees there, I assume. Like, so we have a counterpoint. This is exactly the place where we want to be.
I have a question. How does it work on Stackr? So in which language you code, and like how the proof is generated?
Yep. So right now we have 3 layers. So the first layer is parent chain, obviously. The second and third layer is basically what we are building. The topmost layer is the application. You define your own state machine. You define your own steps of how the state is updated when you get an input. And then you just, like, that's one system wherein the user interacts with the application, and that's all. That's completely Web2. You can even run it in a centralized environment. Then what happens is you take that state machine, you compile it into a provable format. So right now we are going with pessimistic verification. So it's in a sovereign landscape, but it can actually go into like much more provable, like actual cryptographically provable things. But we want to stay with the social consensus. So what happens is the applications now collects all the transactions, and the verifier layer knows about how to generate the proof for that system. So the application during deployment, it shares its state machine with the verifier. It's kind of like running a full node for the application. And then whenever a transaction comes in, like it batches it up, and sends it to the verifier. The verifier re-executes it in a secured environment, and that's kind of like a different trust model as compared to completely L1 versus completely off-chain. But again, once the proof is generated, there is a committee of verifiers. They attest on it, and then that goes on L1. So that also allows you to build like different kind of user experiences. So the application level confirmation is instant. Then the confirmation between the application and the verifier takes a little bit of time, and then between the verifier and L1 takes a little bit of more time. So you can build more experiences around it and basically choose which application wants to wait for what, something like that.
So I guess one thing that I feel like both of you have kind of brought up, and I believe it's also applicable to you, Remi, is the fact that there is a separate layer of I need to compute this heavy operation, whether it's just a proof or a verification. Well, actually, there's no verification, just proof generation or verification of can I replicate this thing. But it seems like it's growing towards we need either a centralized marketplace or just a marketplace of provers who have a lot of hardware and a lot of compute to just make sure everything is correct. And that kind of looks like Bitcoin to me again. Is that the direction we're going in? Is that a good place for us to be in? Or are we just betting on some advanced cryptography to just kind of simplify that compute in the future? Like, what exactly does like the long convergence look like here? Because it feels like it's not becoming more accessible. If anything, it's creating more silos. This was for everybody.
So for us, it's because we're doing FHE. Ideally, we want to use more specialized FPGAs that can compute FHE very efficiently. So to give you a sense, doing operations on top of ciphertext, which is the way you encrypt data in FHE, it's 10,000 times slower than plaintext. So for this, you need specialized ASICs that are optimized for these specific mathematical operations. And so the reality is, yes, we will start small. So today with CPU, we can probably do 5 to 10 TPS. And then down the line with these specialized FPGAs, this is where we can actually scale to 100 to 1,000 TPS. And obviously, by doing this, this also means we have to use specialized hardwares that are initially going to be costly. But as we've seen since 2000, every 5 years or so, generally hardware costs will decrease by 90%. So in the same way, I think in the next few years, once we switch to this specialized hardware, it will be the price point that's going to be the highest. And over time, we will expect this cost to decrease over time. And generally, I think long-term decentralization, the idea is you could end up with specific validators, a set of validators, maybe in the hundreds, that are going to be doing all of this work. But everyone should be able to at least run a light node or light client to be able to verify, but also just submit transactions very easily down the line. I think that's, to me, seems to be the practical approach for most networks outside of Bitcoin and Ethereum. Yeah.
I'd like to add on that. I feel like I agree, like that. Now there's like, it seems you need a stronger prover to generate the proofs. But now there are like technologies such as a parallel proving coming, so which you can distribute the job in a decentralized way. And besides that, what I see coming, I think before ZK being efficient enough to be able to prove on your own phone is that, let's say, even though you have one stronger prover, if you can generate a proof, now you can have thousands of validators that can run on each one's phone. So I think even though we're going to a place where one prover will do all the job, but now everyone here in the room probably would be able to become a validator, because now you just have to verify the proof, and then the ecosystem itself would be more
the same guarantees exist.
Yeah, I agree with that. Like, we are going back to like a compute heavy landscape. But I also feel like once it gets more mainstream, like if you think about it, 5 years ago, the AI part wasn't like wasn't that popular, and we still struggled like training our models and all of those things. But as it went more consumer, so companies started coming up with chips that were specialized in AI compute, and like Apple did such a great job with building their processor. So I feel like once cryptography and all of those things gets more mainstream, consumer hardware would also get much better. So I personally see a future wherein we don't need chains anymore. Everyone is doing just peer-to-peer transaction. Everyone is running a light client in their mobile phones, and they just send transactions over airdrop or something, whatever. I don't know. But we'll be able to generate proofs on the hardware level itself. And once we get more, once we get more attention and more things into it, we'll get better hardwares. So that might not be as crazy to think about doing ZK proofs on mobile devices maybe 10 years down the line or something.
I mean, that would be a be an incredible world.
And our phones are getting incredibly faster as well. So there's also that.
And it's like that twice the amount of speed up every 2 years or something. So amazing. Well, I guess maybe for my last question, one thing that all three of you have in common, other than kind of ideally your love and passion for privacy, encryption, and making real world applications, is the fact that all of you have kind of been through ETHGlobal and gotten your start from a lot of these things here. And when I kind of look at who's actually hacking at ETHIndia tomorrow and this weekend, the most common theme I see is people want to do ZK-related things. And that means we're going to see a lot more experiments. We're going to see a lot more people just trying the craziest thing they can think of and just kind of slap ZK on it. And also, a lot of these things are going to be done for the first time because we're still figuring out what the right tooling is, or what is or isn't possible, or what's actually computable within the limits of EVMs or anywhere else. So what advice would you give to any of the hackers who are trying to play with ZK-related toolkits, whether it's kind of don't do this thing or don't spend time on X, or what did you end up doing when you were building Stackr or Inco or Kakarot? How would you make them use their time properly this weekend?
Yeah, I can share. Like, I think I participated in around 9 ETHGlobals, and I plan to participate more because it's so much fun and you always get to learn a lot. And my approach have always been, whenever I come to an ETHGlobal hackathon, I try to set a goal that right now I don't believe I can achieve. And what I do is I try to leverage the amazing community there is. So basically, I go with a project that, I don't know how I can do it, but I'm sure there's so many mentors, so many sponsors there that can help me achieve that. And what I usually do is that, okay, let's say I want to learn about ZK. I go to who are the ZK sponsors. I sit right next to their table and keep asking questions nonstop. I remember that one of them, even like they went to another room after some time, but like, but in the end we became good friends. So like, leverage the community. Like, I think this is one of the most powerful, like you can pick on so many smart people's brain who have been in the ecosystem for so long, and they are there with you. Like, many times, a lot of the sponsors, they were already like going to all-nighter together, hacking together. So yeah, I would say, like, choose a topic that you don't think you can achieve, pick the brains of the community, and yeah.
Yeah, I think I have 2 points to say. So one of them, to Kartik's point, was don't just slap ZK on something just because you could. Use the right tools. There are so many things which can be solved in a more efficient way without using ZK. So just keep in mind that should be the case, that you're not doing it for the sake of it. So that's one. And the second thing is, if you really think that ZK is something which you can go forward with and have it in your application, there are tons of projects which are doing it. They have libraries and something. So don't start from scratch. Try to research and find out some tools. There might be some niche tools which you just need to dig into. So you might spend more time reinventing the library. So just spend a little bit less time on that and try to find more things, and just use that. And you make sure that your project, whichever like the hero element of your project is, that's the focus and not the underlying library behind it. So yeah.
Yeah, for me, similar to Danilo, I've probably done more than 9 hackathons. For me, I really love hackathons because it's where all the smart people are concentrated. And I've been in space since 2017. I would say like this space is unique because every 6 months or so, there's always something new, novel primitive, novel concepts like proof of stake, or even account construction that kind of reshapes the landscape a little bit. So being part of hackathons, if you talk to sponsors, to each other, we can quickly find out, what are some novel things that you can do or build that's new and can push the space forward. So yeah, and then if you want to play around with FHE, so for us, it's directly integrated to the EVM. It's abstracted away. We actually built a fully on-chain mafia game a few months ago, ETHGlobal NYC, and this is a fully on-chain hidden information game. So this is a novel type of experience. So if you want to play around, feel free to try out Inco for the hackathon as well. And yeah, we'll also be there, so building something fun.
Amazing. Well, thank you all three of you for this amazing conversation, and we'll see you all this weekend.
Thank you.